Kia ora Year 9. This is the third video that goes through the very last few relational skills in the revision booklet that I got cut off by because there's a time limit on the videos, and then some of the extended abstract questions. So again, this will be quite long. Make sure, guys, that you've tried the questions before you watch the video, and then go through it quite slowly. I've given quite a lot of comments in here about both working and also strategies for when we're getting to harder problems. So I've done those first two multiplication ones already. The big thing there, remember, is that we're going to start simplifying across when we've got multiplication, right? So for example, I think question 22 is where I got chopped off. So this one will be 3xy divided by 28, right? There's no more simplifying I can do in there. And then the next one is where I move to fraction division. So this was something that we had quite a few issues with in the number topic. When we're dividing by a fraction, we're multiplying by its reciprocal. So before I start simplifying, I need to have a look at that and rewrite it as follows. And then, and only then, can I look at simplifying here. And I can see that again, I've got the 3 and the 9. So we're going to simplify that, and we'll get a 3 here and a 1 here. That gives me 4a over 15d. Right, on to the next one. So we've got 4x over 9 divided by 5y over 3. We'll rewrite that as 4x on 9 times 3 divided by 5y. And again, to make you practice simplifying through the fraction, we've got 3 over 9, we've got 1/3 here. So here we've got 4x over 15y. Okay, so let's get into these extended abstract ones now. The first one is just a big evaluate one. The only thing you've got going on here is the numbers we're substituting are negatives. And you can see that we've got some powers. So you have to be really careful with evaluating negative powers, whether they're even powers or odd powers. So again, this really is revision from our number topic. First thing we do, though, is we show our substitution. So this is going to equal 8 times negative 2 cubed times negative 1/3 minus 4 times negative 1/3 squared minus 5 times negative 2 times negative 1/3 cubed. Right, and we're going to show that substitution. And no matter how good we are at doing maths in our head, we're always going to show that step, right? Whether you're in year 9 or year 13. Right, now we slowly go through it and we work it out. Right, so we've got 8. We're putting our time signs back in now. So we've got 8 times negative 2 to the power of 3 will be negative 8, right? Negative times a negative gets me a positive, times a negative back to a negative. So 8 times negative 8 times negative 1/3 minus 4 times, now this is going to be negative 1/3 squared will be a positive number, so that's going to be times 1/9, right? I'm assuming if you're watching this video, you're probably pretty good with doing that in your head, so it's fine to go from there to there. And then we've got minus 5 times negative 2 times, and again, this is going to be a negative number because it's an odd number power, so it's going to be times negative 1 over 27. Right, let's clean that up. We get positive 64 divided by 3 minus 4/9 minus, right, because I've got a negative times a negative times a negative, so minus 10 over 27. Common denominator here is not timesing all those together and getting a huge mess. The common denominator is going to be the lowest common multiple, and that's going to be 27. So writing all of that divided by 27, 64 times 9, well, we probably do have to think about that one. So 64 tens are 640 minus a 64. So let's do this long multiplication way. So 9 4s are 36, 9 6s are 54, carry the 3 gives me 576. Right, so 576 minus 4 3s are 12 minus 10. Carefully working that out gives me 576 minus 22, which you can do in your head, but don't muck it up. We get 554 over 27. Now, that's a perfectly respectable answer, but it would be nicer to write it as an improper. It gives you a better sense of the number. So thinking quickly, what are 2 27s? Well, 2 27s are 54, so 20 27s will get me to 540. So this number works out to be 20 with 14 left over. So 20 and 14 27ths. Right, so just again, I would give that a tick, but I like that answer better. Okay, but if you're going to do this answer, don't muck it up and get a wrong number. Next one, very similar. more fraction stuff to chuck in. So pause the video and have a go. Show your substitution. So it's 4 times -1 squared times -1/2 plus 3 times -1 cubed minus 5 times -1 times -1/2 cubed. Right, lots of negatives to work out and lots of powery things. So in here, 4 times, that's 4 times -1/2 plus 3 times -1. So I hope you see how slowly I'm going, guys. I'm probably going slower than most of you. And that's not because I can't do it. It's because I've learned over many years that slowing down eventually will speed you up. So plus 5 times -1/8. And here we get -2 minus 3 minus 5/8. And we can clean that up very quickly to give me -5 and 5/8. So that's correct. So just think about that on your number line, right? It's easy because it's all takeaways. And we could write that as -45/8. So either of those is fine. The next one, and I think maybe, oh no, I've got a couple more to do in here. So now we're on to factorizing and expanding, and then the very last one. I don't know if anyone's still watching, but hopefully you are. Okay, so this very last one, we're factorizing and we're finding first the highest common factor in the numbers, which is 12. Then I'm looking at my x terms. The highest power in the x's here is x to the power of 10. The highest common factor in the y term is y to the power of 6. So we're going to pull all of that out as my common factor. And now we look at each term and ask what we need. Well, we've got 12, we've got x to the power of 10, but we've only got y to the power of 6, so we need another y squared. In the next term, we're going to have take away 2, we need another x squared, and we're good with the y's. Plus 12 what's 48, 12 fours are 48. We're good with the x's and we're good with the y's. So that's my final answer for that one. So hopefully you'll see that's actually not too bad. It looks horrible, but it's not horrible if you get the hang of factorizing. Next one, we're going to expand, and then we're also going to check for like terms. So expanding this gives me -6 x squared y, right, plus 3 x, so it's plus because it's a negative times a negative, so plus 3x cubed y minus 3x y squared minus 9x squared y. So that's all that done. Now we have to clean that up. We can't just leave it with like terms. So looking here, I've got an x squared y. That's different, but this is another x squared y. So altogether I've got -15 x squared y plus 3x cubed y minus 3x y squared. So that's that one done, right? So don't forget about the cleaning up like terms. And just if you're watching, be really careful whenever you see a negative sign and you're doing an expansion. For example, if you had this is a completely separate question. Let's just get rid of that. Oop, wrong. Let's see. There. So if I had 2x minus 1 minus 3x minus 2, remember that when I'm multiplying this out, it's going to be a plus here. So that would be 2x minus 2 minus 3x plus 6. Okay, very, very common. Year 9, 10, 11, 12, and 13 mistake. Right, the very last question in here is to find the term represented by p such that this and this are the same. Now, we haven't done solving equations yet. Some of you are probably going to do this, watch this video like after you've done equation solving. I'm going to teach it to you how we can do it right now. And that's just the idea of matching up. So for this first question, we've got some cleaning up to do on this side. We've got 24 x cubed y squared is the same as x cubed y times itself is equal to 4 x squared y to the power of 4 times p. So we can think of p as just a box that we chuck everything into that we need to make this work. So we've got 24 x to the power of 6 y to the power of 2 is equal to 4 x squared y to the power of 4 times, well, what are we going to need? Well, we have to match up the 24. So we've got 4 watts of 24. So this has to have a 6. Here, we've got x to the power of 6 we've only got x squared here, so we need to be timesing in another x to the power of 4. And over here we've got y squared. Here we've got y to the power of 4. So we need to divide out some y squareds. So p must equal 6x to the power of 4 over y squared. Now, does that work? Well, let's cover up all of this, and let's just look at what happens if we simplify back what we've got here. So you can check that you've got this right. Simplifying this would give me 24x to the power of 6 times y squared, which is what we wanted on the left-hand side. So it works. Right? Remember, this is the left-hand side, and this is the right-hand side. And if you keep on going with maths, you'll see those quite often starting from about year 10. Okay, I'm going to stop the video there because I have to go and teach you guys now. But I've got a few more of the very, very hard questions to do. I will try and get that one done in the next couple of days. In the meantime, use the written work solutions that are up on Google Classroom. Thank you for watching all the way to